Okay, students, today we are going to study a very good topic of thermal physics, which is Newton's law of cooling. As we know, Newton was a very great scientist and he gave his contributions in almost every part of physics and maths. So, we will first discuss this Newton's law of cooling. Now, with this word, we are clear, sir. Cooling means what? So, the fall in temperature. Cooling, what we say, if something is going to cool down, it means the temperature of that particular part or that particular object is going to decrease. Now, here in this topic, we will go in this lecture flow. First, we will discuss the basics. After discussing basics part, we will go for some important formulas. After the discussion of some important formulas, we will go for important graphs. After the discussion of important graphs, we have to see the short trick for solving numericals. Okay, now, and finally, we will look for some good questions. These are not very basic questions, but some of the good questions. Now, for the basic part, uh, numericals, fine. For the basic part, let us start. Suppose here we are having any object. This may be spherical, cubical, cylindrical, or of any shape and size. This body is having a temperature T and it is kept in an environment where the surrounding has the temperature of T naught. Fine. Now, if T is greater than T naught, then by common sense, you tell me what will happen. Will this body gain heat or will it lose heat? Obviously, this temperature is greater than this, it will lose heat. Fine. Now, what we see that here T naught is the temperature of surrounding, but this temperature difference, that is T minus T naught, this is the temperature difference. Difference is always positive, so we will write first the higher unit, then the lower unit. Fine. Then T minus T naught is small. This thing we have to keep in mind. That's why this temperature difference is not very high. So what Newton made observation that the rate of fall of temperature. After some time I will put here minus, that we will see. So what Newton made observation that the rate at which temperature falls, the rate at which temperature falls is directly proportional to the temperature difference of body with respect to its surrounding. Fine. So, in order to remove this proportionality, what we use? Constant. Now, this is logically correct, but not mathematically. Here, now see what is there in mathematics part. This dt is what? Change. This dt is change, and change is always final minus initial. If this body is losing its temperature, so what will happen? Its temperature will decrease. So final value will be less than initial value. Okay. If final value is less than initial value, so the change will be positive or negative? Obviously, it will be negative. Fine. So if this change is negative, here it is positive. In order to make it positive, what will I do? Minus. Now it is logically also correct, mathematically also correct. In order to make it mathematically correct, I have to put here a minus. Now you can say that, okay sir, dt, this is the rate of cooling. This minus dt by dt, the rate at which it cools down, its temperature decreases, is termed as rate of cooling. So this particular formula is termed as Newton's law of cooling. All the other important formulas will be generated from here, and the graphs will also be discussed on those particular formulas. Fine, and the short trick that we will discuss is also based on this one. Now let us see and generate some important formulas from here. Now minus dt by dt is equals to k t minus t naught. Fine, this will go here. So minus dt upon t minus t naught is equals to k dt. Here if you look, what you will get? One more thing, that the integration of 1 by x dx is what? ln x. Now this will come handy here. If I integrate it and put proper limits, remember where the students feel uncomfortable is while putting proper limits. Okay, when the time is zero means when I have started the observation for this body. Let us say this body is having an initial temperature T subscript I. After some time T, it is having a present temperature T. And after some time T, it is having some present temperature T. And when we started the observation, it was having initial temperature as Ti. So this is what? Proper limits. Now, you will have this integration. Let us shift this minus this part on this side. Minus k dt. This is dt t minus t naught with proper limits, temperature initial and here temperature T. Now this integration will be ln t minus t naught. This you can relate from here. You can also write plus an integration constant c, but that does not matter here. Now here temperature initial to temperature final minus k. This one will give you what? T, from 0 to T. Put it present temperature T. Now ln T minus ln temperature initial minus T naught is equals to minus k T minus 0. So what we will receive here? A new formula. Okay, let me write that here, or wait. We will receive a new formula ln T minus T naught is equals to minus kt plus ln Ti minus T naught. Okay, so now we have two important formula. One is this one, another is this one. So the first formula that we received was minus dt by is equals to k T minus T naught. This is the next formula ln T minus T naught is equals to minus kt plus ln temperature initial minus temperature of the surrounding. This is the next important formula. Then we have to make graphs also. on these particular formulas. Now what you will have, if you look at carefully, I can write it as ln minus ln is equals to minus kt. So ln t minus t naught ti minus will be equal to minus k into t. Now what will you have? T minus t naught upon ti minus t naught is equals to e to the power minus kt. So t minus t naught will be equal to ti minus t naught. We will have this thing, and the present temperature, remember we have to focus on present temperature. T will be equal to ti minus t naught into e to the power minus kt plus t naught. This pattern also you have to keep in mind, because whenever we will study the charging discharging of capacitor, the charge and the LR circuit, the RC circuits which are in 12th syllabus, so there also we will encounter something expression like this, and also the graph will also be similar to this. So here we will keep focus on this part also. Now if we have to draw the graph, let us start from this particular formula. Now compare it with y is equals to mx plus c. A straight line graph is equals to k into t minus kt naught. Fine. So this will be y is equals to mx. This will be the y-intercept. Now its slope will be positive here, and the y-intercept will be negative. It will be something like this. A straight line graph, and the slope part will be where k, and this one will be the y-intercept k t naught, the length. Now the next one is this thing, y is equals to mx plus c. For this part the slope is negative, so here ln t minus t naught, here temperature, and we will start, see while here y-intercept is positive, so it will be going in this manner, and the slope is minus k. I hope now these two graphs are clear to you all. Here you can also write y-intercept. This y-intercept is ln ti minus t naught. Now write this. Then this one is the important one. In this case, see, it is the graph of exponential function ti minus t naught into e to the power minus kt plus t naught. You should have the logic to draw the graph. Suppose in case if in exam under stress if you forget graphs, so you should develop the logic. This t I am plotting on y-axis, this t on x-axis. Now put this t as 0. So, suppose if you are not able to remember the graph or something, you should have the logic. That sir, it is e to the power minus, it means it is exponentially decreasing. So it will decrease in this manner, but you have to do the proper labeling also. Put this t as 0. This thing will be 1. Anything raised to the power 0 will become 1. This will cancel out. So the temperature of the body will be temperature initial. Okay. After that, let us say this line represents the temperature of surrounding. After very long time, put this t as infinity. 1 upon e to the power infinity will be infinity. This particular term will become 0. So this t will reach up to t naught. But it will not reach straight manner. It will go in the exponentially decreasing fashion. In this manner, this will go. Similar type of graphs we will encounter in RC circuits, some LR circuits that we will see. One more thing that you can keep in mind, e to the power minus 1 is always 0.368. This thing you have to keep, this particular value you have to keep in mind. It will always help you. Fine. Then, so this particular part, basics, important formula and important graphs are clear. Now we will move to short tricks of solving the numericals. Now, for this short trick part, you have to understand this one, that it is a linear function. It is following some linear relation k t minus t naught. Now remember, whenever anything is following the linear relation, so we can take average as initial value plus final value divided by 2 whenever there is a linear relation between quantities. So the average will be initial plus final divided by 2. Similarly, we see it here. What happens if suppose this body is having some initial temperature Ti, surrounding temperature is T naught. After some time T, the body is having temperature as T final. So in place of dt, what you can write? Temperature final minus temperature initial. In place of small dt, what you can write? T. In place of T, what you can write? Temperature initial plus temperature final divided by 2. Because this will continuously vary. There is continuous variation which is linear. So whenever anything is following linear relation, the average will always be initial plus final divided by 2. Same thing you must have studied in kinematics also, in pressure also. The variation of pressure due to any fluid, rho into g into h, the same thing you must have studied there also. So the same logic we have applied here. So this part is an important short trick for solving the numericals. Now, in the next session, we will look for some good question. One will be based on this one, short trick, and the another one will be based on half of heat lost in some time. So we will be required to calculate that particular time. That is a very good question. And what I want that you should learn that particular result. You should also understand the logic, because the same type of result we will obtain in modern physics also, which is related with half-life. So that we will discuss in the next session.